ray diagrams?
Hi, we're recording.
No.
Okay, Tanner, you good?
Yeah.
So first thing we've got to do is name them. Do we know what the name of each of these types of lens is?
Concave, convex.
Which?
Convex is the circle one.
Yeah, cool. So that's a convex
Define circle.
Shut up.
lens and concave lens. And labelling important parts of it, the same as with mirrors. Lenses have got focal points, except that with a lens, it's symmetrical on both sides. And so each lens has got two focal points. In real life, we can make them so that the focal point on one side is different to the focal point on the other, but for you guys, to keep it simple, it's going to be the same focal length on each side. So, on lenses, they're going to have two focal points.
Oh, I should have measured that. Wait, did I have a voice back?
And the other important thing on a lens is the centre. And on a lens, the centre of the lens is right at the centre of the lens.
So the centre of the lens halfway between the two focal points.
A.
Oh no.
And so the cool thing is, by naming it this way, we can now use those same three rules for ray diagrams that we use. We're going to use the same three rules for ray diagrams that we could use for mirrors. So,
Are they the same distance? They must be
rule number one.
Oh, wow.
What's rule number one?
Wait, but there's two focal points.
out through focus.
And there are two focal points.
In focus.
You should.
So it comes as a
Oh wait, so it comes in both.
Well, it comes out.
Boom, 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 boom. And that makes sense because the see-through.
No.
Wait, but where's the person?
No, that does make sense.
Rule number two is going to be the opposite, right? And
The first rule is actually in focal, out parallel.
I am rewriting them the other way around. You'll see why.
Oh, okay.
It doesn't matter.
Yeah, why would it matter?
Funny ways.
Oh, do we have to write them again?
I'm just because I know that some people were away when we did it the first time.
Yeah, I want to spit. I've got them written down.
Drop kick.
And so we're going to have a go at applying those three rules. We're going to start by doing convex lens. So, same as with mirrors, it's really important that when we're drawing these diagrams, we do it to scale. Otherwise, it's not going to work out for us.
The third gear. The third gear.
This is what fishing is.
See my hand?
Yeah, fishing is.
See this one? So how do you put the third gear?
So I can see.
One side will be
Well, we
better.
can.
Yeah, but yeah.
So shouldn't that mean that everyone
see.
will be finished?
Yeah, that's pretty cool.
Look, Stevenson, why do flies have so many eyes?
Because they're power.
I only have 2 eyes.
The bugs. They're bugs.
Because they're bug.
Wait.
So I can see everything.
So we should draw this
That's
out.
all.
You probably should. That would
Okay,
be a
so
good idea.
sketch that one down and we'll have a go at those three rules. Both the focal lengths are 3 and the distance to object is
but one
5.
side is still going to be out and the other is still going to be in. Ask side.
And it's So,
That shit was good. Good. He's fine.
Oh, should we make our person 2 centimeters high, do you think?
yard.
What?
Okay.
Just wait for everyone to be ready. We're back here. Are you doing rays already, Johnny?
Oh no, were we not meant to?
Okay.
Cheat
If we're all ready, let's just hold off drawing rays because it's a little bit of a different approach to the mirrors.
No.
So, main difference between mirrors and lenses is that mirrors reflect light, lenses, the light passes through. And the reason why I've flipped around the order of the rules in parallel out through focal point is that most of us know that magnifying glass, like a convex lens, you can use it to focus light on something. So we're all pretty familiar with the idea that light coming in parallel is going to be refracted to go, where's that going to go? Out through focus. It's going to pass through the lens.
Of course, because there's two.
Mm.
So cool.
So cool.
So cool.
It's going to go through that focal point. So the reason why I put that first rule as in parallel out through focus is that it helps us remember which focal point to use. We have to use both focal points. So if we've used that one with our first ray, we have to use the other one
Oh my god.
with the second ray in through focus.
Oh my god.
Todd, chill.
You make it.
Don't lose your cool.
I am a loser.
There it goes, in through focus and out parallel.
Yes, sir.
Uh,
That's the second one, right?
Why would you do that? So
Yeah.
that's toxic.
It does, in through focus, out through focus. That's obviously ridiculous.
Should our lines be parallel?
Mine.
Yes.
Thanks, Harry.
Bruh. It's turning out way bigger than I thought it would. Wait, Johnny, does yours look at this?
Mine hasn't done it yet. Mine hasn't done it yet.
And the third one,
Wait, into focus out.
in and out straight through centre.
Wait.
So we're going to line up our
Our duty's here.
top of our object with the centre of the lens, because the centre of the lens really is at the centre of the lens. And so that ray just goes straight through the centre of the lens.
Oh, they'll meet at a point.
Is that where his head is? So he's backwards. He's upside down then, yeah? The exact same height.
There's no dude though, because it's not reflected.
Okay, so let's sketch up the
Little fella.
image and see what it's like.
Wait,
He's bigger.
But there isn't.
there is a dude. But it's not the same dude, is it?
There's another dude.
It's a different dude.
Why are there so many dudes?
Yeah, that's a different dude, right?
Nah.
Because you're
Same
the
dude, same dude.
you're that dude looking through
Same dude.
on this side.
Same dude.
I'm a dude.
It's good.
Image is 3 different words to describe the image.
I'm saying
Enlarged because it's fractionally bigger. If we measure the height of it, is fractionally higher than
That's
the height
it.
of the object. So enlarge. What else?
Inverted.
Inverted because it's upside down.
And
Real.
real.
Is that always real?
Yes, man. Here's some like being
We're gonna say.
That's cool.
Or is it on the other side not real?
What we're going to have a go at, just to finish off today, we're going to have a go at moving the dude a little bit closer to the lens. So, sketch yourself up a second example.
Can it even be
Nah.
virtual with lenses?
Yes.
No.
We're about to find out something.
The same scale? Or really small?
I made mine way too large.
Same.
It says it.
Just say.
Hello? Just it?
So the good ones actually like meet up to the.
And let's go with...
Reeds.
Yeah, what happened to get you, boy?
How big we have to draw. Oh, I'm worried then.
Market spot.
Hey, what?
Market spot.
Marcus Brownlee.
Marcus Brownie. Oh,
Oh wait, no, the other end.
Hey, sketch yourself up a little diagram like that.
Relying.
Yes.
So this time the dude is 2 centimeters from the lens, and the lens has a focal length of 4 centimeters.
Interesting.
And the dude's 2 centimeters.
If you draw rays that you're 100% confident with, if you wanted to, otherwise in 1 minute we'll do them together.
dude.
No, definitely.
Okay.
So what's the first ray?
Isn't it supposed to be concave?
No, convex lens. What's the first ray?
Still doing it.
In through the parallel.
In parallel. And we know that any ray that goes in parallel is going to go out
Focal.
through the focal point on the far side. So in parallel, out through focus. What's the second ray going to do?
Through.
Into focus out.
In through focus. We've got to use the other focal point. So the other focal point in through focus. I'm just going to extend my line here.
Wait, how do we go around parallel?
Or go that way. Don't move the top.
It's not going this.
In through focus. So line up the focal point with the top of the object.
Wait, that's not.
That's what I mean. When are we going parallel? Oh.
In through focus. And then out parallel.
Hold the jar.
Would it be Donald? Come on.
Good morning, Kanye.
So rule number 2, in through focus,
Hey,
out
what did
parallel.
he say?
Rule number 3, in and out straight through
Okay.
centre.
That's kind of not real.
Hold on.
So when are they all gonna meet up?
I got a bad feeling about this.
So what's the problem with these 3 rays? They're never going to meet up. What can we do? How do we solve that problem?
We don't.
Move him high.
Person needs to be moved.
Further away.
Move the person solves the problem, but how can we solve the problem without moving the person? How can we find that image? Dotted lines back to be
Oh,
they're
yes.
diverging, but on the virtual side of the lens, the side we know that no light's going to reflect back off the lens because it's a lens, light goes through.
Oh,
But if we put our eye over here, where do these rays appear to come from? Let's check that out.
When I was stood up, mate. Is it like here?
do they? How far away is the dude again?
Mine doesn't work.
How far away is the dude?
That red one appears to come from there, and the orange one
And he's
appears.
2 centimeters tall. Sonic, can you know it? Kind of light.
Cringe.
You're making me cringe. How tall is the dude?
What dude? This
Yeah,
dude.
this
Well,
fella.
my lines don't meet up anyway, so.
Appears to have come from there, and so our
So he's a big.
Is he or is he not?
It's literally a Attack on Titan.
let's sketch on our image.
It'd be like,
There's the hair.
Messy.
Messy, but.
Attack on Titan, you said.
enlarged.
So what is our image? Image
It's like
is
right behind him.
But you
That is so
You
scary.
gotta see it. So I've got a big, right now I've got a big dude right behind me.
enlarged because it's bigger. What else?
Virtual.
That's kind of scary.
In virtual.
Irregular because it's the same way up as the object. Virtual because we had to draw dotted lines to form it, and the image is forming when we know that no light can be. Light can't reflect back off the lens. So if we put a piece of paper there, we're not going to see anything. Whereas with our real image here, you should be able to find that with a convex lens, you can put a piece of paper up and you should
Is it actually a
actually
piece of
see
paper?
the image forming up.
It's gonna be like a piece of wood or something, or does the light have to come through? Because I already did it before, read this down. Top size.
So if you haven't played with your convex lens to make an image on a bit of paper, do that. You guys should get a real image of the outside world.
So I can see all
Wouldn't, if we use the rules though, would the convex? Would the concave?
Let me see where we're up to. Have we got far enough to do that?
No.
Hold on.
Oh, I don't get this. I'm thinking it's
No, go away.
I'm doing the fun.
See, go away.
Okay.
Go away.
Yeah, I'm trying to scan it.
Okay, coming out to you as a homework, you can just use exactly the same maths for lenses that we have used for mirrors.
Sweet. That's easy.
Exactly the
Easy.
same maths. And in terms of, some of you have been emailing me about when is the physics 2.1 due. I think we're just waiting for Momo to get some data, and then everyone will have data. We can see
And me, I need data.
I usually get a little bit.
Wait, so it doesn't.
Are we done?
It doesn't. It's not that bright after.